In the previous lesson, we looked at creating instances of assets. Now that we know what we're doing with that, we can then start having a look at creating bespoke data that's not based on a UDT for that particular asset. So you can see in the project here, I have a folder for analog devices and I have a folder for valves. The naming convention denotes what type of asset it is. So we have DP for differential pressure, FL for a flow instrument, IL for a level instrument, and then we have QI for a quality instrument. And those quality instruments are of various types, so different actual instruments, but they have exactly the same base data. Now, if we go and have a look at if I just make this a little bit smaller, if we have a look at the data type that's being used for all of these, we can see that they are all analog instruments. So they're all the same data type. They just have different names for the asset, but they won't all work the same. So for example, looking at the level transducer, which I have open here, if we have a look at the data inside this, particularly the alarms, we can see that the alarms that are available are high alarm, low alarm, low alarm, and out of range, which is typical for all analog devices. Remember that you don't need to use all of them. You might find that you sometimes have a level instrument where you only want to use low level. That's the only thing that you need to raise an alarm on. But what if we need to use more? If we need to use more alarms or create more alarms for this particular asset, especially if another asset doesn't require it that's the same type. So if we had a second level, we don't want to be adding new alarms in here at the UDT level that other instruments of this type don't need to use. So the best thing to do in that situation is to add a new row, and I call this row bespoke, and then we create a struct. So we went over this briefly in a previous lesson, the difference between a UDT and a struct. A struct is an on-the-fly structure, but you can't add if you update a struct in one place, it won't update other instances of that struct. They're not linked. So if you were going to pass this structure to an interface, you'd have to create exactly the same size struct, but if you updated one of them, the other one wouldn't update like a UDT does. And in here, we might say, let's have a look at the actual filter that we're building towards. So the filter level is sat up here, looking at the media. The water sort of comes in from the side and would fill this vessel up, and we'd be detecting the rising level of the water. So we can have a high alarm and a high alarm, but if we didn't actually want to create an alarm on that point, we wanted to create an interlock, we might want an interlock that says you're at the weir level here, to say that you are at the lowest you can be whilst the washout valve is open. Now high, low, and low alarms don't really do that for us because they're telling us something's wrong, but there isn't anything wrong at this point. It's something that we need to create a control from. So if we go back to tier portal, in here I would create a bespoke variable, and that bespoke variable would be something like at weir level, and we'd have it as a real. And now what we can do is, when looking at IL1, we can reference the bespoke structure and pick out at weir level, and SCADA can reference this as well, so it can be typed in from SCADA or HMI, and we can use it for our interlocking code. But it's outside of this typed data here, and that's really important to understand, because if I was to go and create another level, if there was a secondary level or even one of these flow meters, they might not have the same bespoke functionality. But what we're doing is adding bespoke functionality whilst retaining our standard functionality for that asset type. And I know I'm saying it a lot, but as we go through the course, this stuff will become easier to understand when you see how this stuff actually integrates with logic, function blocks. When we start seeing things move on HMIs, you'll see why the bespoke approach makes sense instead of having it inside the type data. This gives us a much higher degree of flexibility when it comes to creating something for a particular asset. Now, I've had this question asked of me before as well. Why don't we have one big bespoke data block? And again, it comes down to the same thing that I spoke about in the last lesson. Every time you add something to a data block, Tier Portal is going to want to recalculate that data. Unless you're optimized and you have a memory reserve, you might get away with it that way. But if we had all of our bespoke data in one big data block, what you'll end up finding is every time you needed to add to that, or if you needed to modify your project, suddenly you're running the risk of losing every single bespoke bit of data. Whereas if you do it this way, where the bespoke sits underneath the parent object, if I went and added in a new variable here, only this object is affected. So only this one would have to reinitialize. Now, don't forget that if you modified the UDT, all of these would need to reinitialize because they all use that object. All of the memory would have to be reallocated. So hopefully you understand there why having the bespoke relative, it's a hierarchy. Like we're the bespoke is a child of the parent, which is ILO1. And by doing it this way, it means that we can sort of put our data in designated compartments that are relative to the asset that we're working with. And to finish, just before we sign off the lesson, don't forget to click retain, because if you don't retain your bespoke values, unless they're things like indicators and things like that, but this is going to be a set point on our HMI. If you don't click retain, if the power goes off, you're going to forget this this value that comes from the HMI. You'll also notice that the same's done with UDTs. You aren't able to tick individual ones, and you can't for a structure either. It's got to be everything within that structure is retained. And we'll come on to set points a bit later in the course and what this is used for, or how I use them, because it's worth understanding and it'll help you out a lot if you're doing live updates and things like that.